All right, one last topic on permutations. There are times where you repeat elements of the set that you're trying to permute. For instance, how many ways can the letters in GOGS be permuted? Now, why did I choose GOGS there? Well, that was one of my high school nicknames. When I was in high school, I played soccer and basketball and I wore these obnoxious sport goggles, and so everybody called me GOGS. But anyway, it works for this example kind of nicely. So GOGGS. And so if I wanted to permute the letters, well, there's some repeated letters in here. And so if I just start doing this like I would with any other word, or letters in a word, you could start with the way it's spelled, GOGGS, and then, okay, maybe the next permutation I just switch two of the letters around, so it's GOGSG. That makes sense, that's a new permutation. And then that's every combination with GOG. So maybe I'll start with, the first GOG. So maybe I'll go GO and then I'll use this G for my third letter. Then I still have another G and an S to use. So I'll put those in this order and then stick with the rest. So there's GOGS. So that's everything that could go with letters 1, 2, and 4 as the first three, I guess you could think of it. But now you're starting to see that there's repetition here. I've already got 2 copies of the same permutation in each of these slots here. And so there's repetition. And remember that permutations require the order to be the same. And so you could really count this one and this one as a single permutation, not 2 separate. Same with this one and this one. They're really a single permutation, not 2 separate permutations. And so if I were, there's lots of different ways to scramble these letters, but because of the repeated G, there's going to end up being a whole bunch of what would be distinct permutations end up being the same thing. And so I could make a list of all these things, but it's going to get long, okay? So remember, if these were distinct letters here, then the number of permutations would be 5 times 4 times 3 times 2 times 1, 5 factorial, which is 120. I don't want to make a list of 120 and then count up the duplicates, okay? So there's a shortcut to this. And the formula for the shortcut is this. So I take the 5, n equals 5 here, take your 5 factorial, and you divide out a factorial of the number of repeated letters. So I've got a repeating G that repeats 3 times. So I'm going to divide out 3 factorial, okay? And so what I'll be left with is, 5 factorial is 5 times 4 times 3 factorial. And then you have the 3 factorial, so those cancel out. And you're just left with 20 total permutations for those 5 letters, okay? So by repeating the G 3 times in there, you really reduce it down from 120 permutations down to 20 permutations, because all the rest are going to be duplicates. There's going to end up being 100 duplicated permutations somewhere along the way in there. So that's quite a few. But anyway, 20 distinct permutations will exist. Now, if I had, let's say, maybe I wanted to look at the word permutations and I wanted to permute them, the letters, right? So in permutations, there's a double T, but everything else is a single letter. I was thinking something else would be duplicated, but it's not. So anyway, we've got a double T. How many letters are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We've got 12 letters. So that would be 12 factorial over the duplicated T, which is 2 factorial. That's it. 12 factorial over 2 factorial. Now that's not really going to help us simplify things. It's still going to be 12 times 11 times 10 times 9, 8, 7, 6, 5, 4, 3, and then the 2 and the 1 cancel off. Well, that doesn't help us out a whole lot, honestly. that's still a big number. Equals big number. Exclamation. So I'm not going to calculate that right now, but that's how you would do it. I don't know, what's another word that has some duplicate letters in it? How about addition? I don't know, I'm just thinking of something mathematical here. So addition has a duplicate D and a duplicate I, right? DD and II in there. So there's a total of 1, 2, 3, 4, 5, 6, 7, 8 letters. So it'd be 8 factorial over. Now the double D gets a 2 factorial on the bottom, and the double I gets another 2 factorial on the bottom. So you actually multiply by all the duplicates that occur on the bottom. So that would give me, well, oops. I guess I'll write that underneath. I have more room. 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And then on top, or on the bottom, I've got a 2, a 1, a 2, and a 1. Well, I can cancel off some of this stuff. I've got another 2 here that cancels with maybe the 4, reduces anyway. Okay, so I can just do some canceling and maybe get a nicer value here. So 8 times 7 times 6 times 5, and then I've got a 3 and a 2 left over up there on top. So whatever that comes out to be, you can multiply that out. 6 times 5 is 30, that's 180. 180 times 56, whatever that is. So do that on your own. Anyway, so that's how many permutations of addition there is. You know, if you wanted to permute, I don't know, what's a different word that's kind of, let's see, what's another word that has, how about some repeated letters like Arkansas? I don't know, take another state, take a state's name. Your book does some good ones like Mississippi and Tennessee and stuff, so I'm thinking of Arkansas. That's not too bad. There's some repeated letters in there. So we've got a triple A and a double S, and then an R, a K, and an N. So I've got some single letters in there as well. So on this one, you take the total number of letters, 1, 2, 3, 4, 5, 6, 7, 8. So that's 8 factorial again. Over the triple A gives you a 3 factorial, and the double S gives you a 2 factorial on the bottom. So anything that's repeated, the number of times it's repeated gets a factorial on the bottom. And so on this one, you know, you get your 8 times 7, 6, 5, 4, 3, 2, 1. You have a 2 and a 1 from the 2 factorial, you have a 3, 2, and a 1 from the 3 factorial. You know, you just cancel stuff, right? The 2's, I mean, the 1's you can cancel or not, that doesn't matter. The 3's can cancel. Here, I'll take the 2 off there with the 4, and so the 1's are all kind of useless. So we've got, what's this, 8 times 7 times 6 times 5 times 2. So it's 10, 60, times 56. So it's 1/3 of that one. Anyway, so kind of some neat examples, and you can kind of see how that works out. The general formula for this is that if you have n elements, and you have one is repeated p times, one is repeated q times, and so on. We'll just go with p and q for instance. Then you'd have the number of permutations is n factorial over p factorial q factorial. If you had another element repeated r times, you would put an r factorial on the bottom, and so forth. So however many repetitions you have, you put that number on the bottom. of the fraction with factorial. So anyway, just a neat little shortcut if you have repeated objects that you're putting in your permutations. That way you're not double counting the same permutation multiple times.